Suppose in the substations, generally we will consider the substation we are having 33 kV feeders 1, 2, 3, 4, 5. These are the 33 kV feeders which are connecting to the transformer, and transformer is connecting to the double bus, and two lines are going out from this bus and a coupler, right? So we will feel what is the maximum worst condition in the substation. In the substation, we are not having these machines or any motors, right? So these DC loads are mostly of relays, mostly control and protection. So we are considering the worst condition that a busbar differential protection operated. Suppose if a busbar differential protection is operated, then all the breakers which are connected to this bus should trip at a time. How many breakers? 1, 2, 3, 4, 5 breakers are tripping at a time. So for this master AAA energization and everything, we require some DC load, right? That is, I'm considering that suppose my continuous load is this, and I'm saying that, okay, my protection was operated at 60th minute and it exists for 1 minute. And after that, I found that is a normal thing. So I closed the breaker. That is again one. And finally, again, I am taking this operation the same. The busbar differential protection again operated at the end of the cycle. You can change these columns, these pillars across this wave. You can place this here. You can place this here or here, wherever you want, you can place. You can place the occurrence of this 3 times, 4 times, depends upon your choice. But rarely, it's a busbar fault is a very, very rare. So it's better to have 2 times in the entire cycle. That is also very, very probability having very, very, very low. You know one thing, the probability of failure of the AC supply is very, very, very low, because we are having 2 transformers and we are having a DC set. If the both failed, then the battery has to come. Transformers as well as the DC set. So you can find how the reliability we are in. In that condition, the failure of the DC, failure of the battery, and failure of the AC. In that period, the operation of double bus bar 2 times, 3 times, it's highly impossible. I cannot say it's impossible. It can be, but probability is very, very, very low. So just think in that context, and you have to prepare your own duty cycle for this. So after preparing the duty cycle, you will come to know that, at first half an hour, the battery should have capability to feed, suppose, 30 amps of current. And after that, there is some intermediate load which is existing for a next minute. So the battery again has to suppose to meet that requirement. And again, there is some non-continuous load. If we just take this an example with our everyday life, suppose if I want to install a battery in our home, inverter and battery, then I will just check out. So what are the lights? What are the fans in my hall, bedrooms, kitchen, right? So I am taking all the loads, and I am just considering that what are the loads just generally will be on when the power is lost. So if you think, just on my knowledge, I will say that when the power lost, always my rotor will be on, because I want uninterrupted Wi-Fi. Otherwise, it will hamper my work, right? So the rotor, whatever the supply is, so I am considering that on my battery one. The next is a single fan in the in any one of the room. Any one of the rooms, single fan should be continuously loaded. And sometimes, if my family is watching any new movie, they should not supposed to switch off the television, even the power cut. So I have to give some time for the television also. So I'm considering that they will see the television for next 15 minutes or next 20 minutes. So it totally depends upon your requirement. So accordingly, and suppose if there is some washing machine on at that time, the power was lost. and the action to be continued. Suppose if you want to take that washing machine also into this battery sizing, yes, you can put, but finally you're increasing the capacity of your battery bank. That's it. So accordingly, it's totally your requirement. In our house, we are not much giving the importance to this all the main items. We are just giving for the fan, light, and for rotors and some power sockets for say, charging as a charging for my mobile or laptop. That's it. So remaining, if you are having want to spend more, you can add these also. So it totally depends upon your requirement. Team. You can select, you can choose the duty cycle depends upon your requirement. So after finalizing, after developing this duty cycle, then you are trying to calculate what is the ampere hours, the capacity of the battery required required to withstand or to supply this the power the load what you mentioned in the duty cycle. Then you are finalizing with battery capacity like 100 Ah capacity or 200 Ah capacity. In that, you know that we are having different types of batteries like Exide, Amaron battery, Exide battery, all these, right? So you're selecting one 100 Ah battery. In that 100 Ah battery, again, this Amaron battery or Exide battery, they are having some characteristics. They are saying that, oh, my there is some temperature aging for my battery. There is some aging factor for my battery or some design margin. So these are the things generally you can get from the manufacturer catalogs. Otherwise, you can refer or you can refer to the IEEE 485, which talks about this VRLA rating of the battery. So there also you can find these and you can employ. You can have to multiply those factors with my derived result of 100 AH. Then you can finalize. You can figure. You can concluded with the exact requirement of your battery.